My name is Nora Sackett. I am the director of the State Office of Strategy, Science, and Technology. I'm super excited to be here with this panel that I don't know if I'm quite qualified to be talking to, but really excited to talk about it. I wanted to just give a shout out to Zach. I sort of first entered this realm. It was like a year ago, maybe. I'm mixing up the calendar, but Zach approached me at the Economic Development Department to talk about the state of New Mexico joining Elevate Quantum, and the assets of New Mexico were already a part of that with Sandia and LANL and UNM and CNM, but about the formal state government joining. And I wouldn't say I was a skeptic. We'll say I was uninformed. And I'm so glad that we said yes to Zach, and look how far we've come. And I'm so excited about the promise of everything this holds. So I'd love to introduce my panel, and this is not in the order that folks are sitting in, so forgive me. Super excited to be joined by this wonderful team of folks from the quantum industry. We're joined by Kristen Pudens, the Vice President of Research Collaborations at Atom Computing. Sergio Boixo, Senior Research Scientist at Google. Fantastic. Philip Farah is the Vice President for Strategic Partnerships and Sales at IonQ. Corbin Tillman Dick is the founder and CEO of Maybell Quantum Industries. Nate Gamelke, I hope I'm pronouncing that right, excellent, is the co-founder and Chief Technology Officer at Quira. Jenny Strabley, we just heard from, VP General Manager at Quantinuum. And Raphael Alexander is the Senior Research Scientist at Xanadu. What an incredible assortment of folks we have here representing the quantum industry. So thrilled to have you all in New Mexico. So we've been tasked with discussing why quantum and why New Mexico, and I think Jenny gave just the most perfect setup to sort of dive deeper into that. So I'd like to just level set a bit first. I think there are probably more people here who are very familiar with quantum than aren't, but for the benefit of us all and to just hear a little bit about your thoughts on the industry, if you could each kind of touch on the why of quantum computing and quantum technologies, the work that your company is doing and what it sees for the future. I know that's a weighty question, but just a little summary of what we're looking at. Yes, perfect. Is that on?
Is it on?
There we
Yeah.
go.
Okay. Thank you. Philip Farah, IonQ. Why quantum? Simply because we're not going to be able to solve the most complex problems using classical compute. Classical compute is reaching its limits. Why quantum? It's because, according to McKinsey, $1 to $2 trillion of value are going to be created by 2025, economic value that is. And it's an incredible opportunity to pass on. What are we doing in order to take advantage of those? At IonQ, we're pursuing a balanced strategy where we're saying, not only do we want to build high performance systems, we want to build systems that are designed to scale, because we know that in order to generate value, we need bigger computers. And we want to build computers that are today ready to be installed in data centers, so that you can take advantage of those, and our systems are ready. And we are thinking about quantum computing in the context of quantum communications and quantum sensing. In other words, if you connect two quantum computers, you can operate as if you had a mega quantum computer. You don't double the capacity, you take it to the power of the number of qubits of the other quantum computer. And the possibilities of connecting quantum computing to quantum sensing and being able to extract and interpret information are really, too significant. And we're designing our approach with this in mind.
Thank you. So my name's Corbin Tillman Dick, and I'm the founder and CEO of Maybell Quantum. And my path into quantum was a little bit different than most of the folks up here. I think most of you are physicists. I studied mechanical engineering and economics, and then I spent 10 years as a strategy consultant at the Boston Consulting Group. And throughout that time, I was always working on cutting edge tech, mobile wallets, AI, augmented reality. I got to do a bunch of work around those. And then I had the opportunity to lead our first quantum case. And I realized during that case, a couple months in, that for the first time in my career, I was jealous of my customers. Sincerely jealous, because This is the most important thing we're working on as a species right now. We have a lot of good stuff going around climate tech, around AI, around all of these different things. But quantum provides a universal unlock across all of these most important technologies. If we get to a world where we have zero net energy carbon sequestration, it'll probably be because of quantum. If we get to a world where we end infectious disease, cure cancer, it'll probably be because of quantum. If we get to a world where our AI models are able to become true superintelligences, it will probably be because of quantum. This technology will be as transformative as anything we've ever done eventually, right? And it's not coming crazy fast. And I think folks up here would generally agree with that. This isn't a 3-year technology or a 5-year technology. This is a generational, even civilizational shift in what we can do as a species. And then why New Mexico? It's because you guys have done the groundwork to build this industry. I think the number was 8 Nobel Prizes across Colorado and New Mexico that are directly tied to quantum research. We've been here to do the work that generates the Nobel Prizes. We need to make sure we're still here when it's time to cash the checks. And that's what this next 50 years is going to be about. And so, when we were first building Elevate Quantum, Zach and I founded it together. We were trying to convince Colorado that it made sense to pull in New Mexico. They were candidly at the governor's office a little resistant. They said, "Why share? We're doing so well." And it was because there's no way that $100-odd million gets poured into the Colorado quantum ecosystem without a ton of it going to New Mexico anyways. We have to use the fabrication capabilities at Cint. We have to be partnered with the Mesa Fab, with Los Alamos, with Sandia, with UNM. And the workforce development work coming out of New Mexico in quantum is truly second to none. And so there's no way to do this without New Mexico, but we need to make sure that as we do it, New Mexico participates in a way that allows them to share in the long-term benefits.
Hello, my name is Raphael. I'm a research scientist at Xanadu Quantum Technologies, and our mission is to build quantum computers and give them to everyone who wants to buy them. Sure. My connection to UNM is I actually did my postdoc here at UNM with Ivan and some other professors. So at Xanadu, so why quantum? We've heard a lot about all the great applications it will bring, but why also invest in quantum research? Why quantum is another aspect is, why do we need to be focusing on this now? Is exactly as you said. It's going to take a while. There are really, really hard research problems yet to be resolved to get us there, and that needs to be addressed all the way at the level of educational systems and build up to that. At Xanadu, to say a little bit, we're doing, it's a full stack company. We're doing everything from theoretical research. So I lead a team of 30 theory researchers developing quantum computing blueprint that's better. There's still research questions there. We're developing the hardware as well in-house. We have also working on software that's going to run in the quantum computers, something called Penny Lane. We work a lot with universities to make this available as an educational tool to increase the fluency of quantum in education, and also we work with users to find new applications of quantum technology to problems that they need to solve. Big companies, So.
Thank you. So, why quantum for me is it's fascinating. And I think everybody's here because they agree with me on that point, right? It's transformational. We've heard a lot about that today. And I would argue, yes, it takes a while if you're used to the time curves associated with classical computing, but I would argue that it's accelerating. And I feel like we're at a really exciting time for the industry. And atom computing is right there at the forefront. So at Atom Computing, we are building quantum computers. out of atoms, neutral atoms specifically to distinguish them from our esteemed ion trapping colleagues. So we have demonstrated an array of 1,225 qubits of atom computing. We're building quantum computers at scale for practical use and for error correction. And we are laser focused on that fault tolerant vision and on that gate model that enables the threshold theorem for quantum computing. And it's really exciting to me personally to see the feedback loop that's there tightening, right? So when I say it's accelerating, it's because I've seen the quantum industry developing for a long time. I was putting error correction code sideways on a D-Wave chip in 2010, and they didn't fit quite how they were intended to fit based on the theory work that I had access to, and I was sort of part of that theoretical error correction community. But like Corbin, I am an engineer, and so I wanted to put it on a real platform, had access to one, and it was a mapping exercise. And I've seen that mapping exercise play out time and time again through different modalities. And I see the loop of iteration tightening. I see that we're able to provide systems at scale and capabilities that enable that loop. And so although we're in for some development until that reaches a fault tolerant scale, the interplay between the communities and the accelerating pace of development makes me really hopeful for the future of the industry, and we're ready to build it at Atom Computing.
Well, it's so many good answers. I'm not sure that I'm going to answer these questions any better than this panel and a governor and so forth. But my name is Nate Gemelke. I'm one of the co-founders of Quera Computing. We're a startup in Boston, and we are also building quantum computers out of neutral atoms. But I'm very happy to be here in New Mexico today. I think there's a good argument to say that if you really want to have a lot of impact on the world, assemble a lot of bright minds down in New Mexico, shut the door, don't open it until you get it done. And what you will likely have accomplished when you're done with that is you will have taken something small and made a huge impact on the world. And so personally, that resonates with me because that is something that I wanted to do with my life. I wanted to take a small thing myself, growing up in the Midwest, and have a major impact on the world. And I think, in a large part, that is exactly what quantum computing is trying to achieve. There was a New Mexico scientist, Richard Feynman, who said in the 80s, when I was growing up, we ought to compute with small quantum bodies. And if we do, we can compute in ways that we haven't been able to do in the past. And actually what he was doing in New Mexico was inventing classical computing, right? He was one of the inventors of the hand calculator. And I think it's amazing that all those years later in the 80s, he was describing a method for computing that has transformational power based off of something very small and something very simple. And in fact, I think my colleagues at Atom Computing will love that I'm pointing this out. But what Richard Feynman said is, you ought to just get a bunch of interacting spins, just a handful of them, and get them to interact in the right way to represent a computation. And you really should do this with the simplest thing that you possibly can. And he literally said, maybe you should just get a handful of atoms next to each other and have those spins be the electrons in the atoms. And that's exactly what we and our colleagues at Atom Computing are doing. Many Nobel prizes later in the technology arc, after having invented laser cooling and optical dipole traps and all of those things, we are now in a position to take that technology forward and really take some of the smallest, simplest things on Earth and make a major impact with these things.
I'll remind ions are atoms too.
Broken. They are broken.
So one thing that we don't always talk about with quantum computing, we talk about the intractable problems that it'll solve and speed ups of those problems, but we also don't talk about the power consumption that goes into those calculations. And quantum computing has the promise to do these intractable problems at a different energy scale than if you tried to do those with a classical approach. And just one data point that I'll add to the conversation, we did a quantum advantage algorithm. Actually, Google was one of the first to do it. We did this back in May, and we did it with 10,000. The power consumption was 10,000 reduced from if you did it with a classical computer. So that's a big number. That's as these systems scale. So that system is not at scale. It's just 56 qubits. So that power consumption of that quantum computer will grow, but it won't grow linearly, for instance, with the number of qubits. So I think that's a very exciting area also that's not spoken about enough, that as we think about these high performance computing, the energy scales to run those and do the types of things that we're doing today with like ChatGPT, it's really going to tax the whole ecosystem. And so being able to now bring quantum into these as an accelerator to work along HPC provides not only an accelerant for the computing, but something that we think could be more sustainable.
Hi. Yeah, hello. My name is Sergio Boixo from Google. I actually did my PhD here in UNM. And then, yeah, exactly. So I'm one of the alumni that was there. So I started my career here. Now I am a principal scientist. I'm the oldest member of the Quantum AI team at Google. So one of the founders of the Quantum AI team. So why quantum? Well, I think Ivan said it best. Is the second quantum revolution. There was already a first quantum revolution, like semiconductors and things like that. We wouldn't have all the modern technology that we have is already based in quantum mechanics, lasers, semiconductors, everything like that. But then we have learned amazingly that if you actually use quantum logic, then you can do computation in a totally different way as well. And there are problems that you can only do with quantum logic, not with classical logic, or it's exponentially more expensive with classical logic. You wouldn't be able to do it. The most notorious one is simulating all, chemistry and physics, which is all quantum, because again, quantum is already 100 years old, and all modern chemistry and physics is quantum mechanical. So if you want to simulate chemistry and physics, you can do approximations, but the only way to do a bunch of things is going to be using a quantum computer. So that's why. So we want to do quantum. It's the second quantum revolution. It's going to allow us to simulate the basis of all industry, which is science, which is chemistry and physics. So why is Google doing quantum? Well, Google is a computing company. And as I just said, there are certain things you're only going to be able to do with a quantum computer. And being a computing company, well, Google, wants to participate in the second quantum revolution, and if possible, lead the second quantum revolution. So what we're doing at Google is we're building quantum computer, a fault-tolerant quantum computer based in superconducting qubits. And the reason is basically when we started the group, Google didn't have a quantum program. We were using whatever was available in the market. We quickly realized through careful benchmarking that you couldn't rely on what the industry was offering at the time anyway. So we just decided to bite the bullet and actually start a program to build a quantum computer at Google. And that's what we're doing.
Thank you. So next I'd like to talk a little bit about, New Mexico assets that we've heard so much about. When Ivan had first reached out to me about this panel, I was very embarrassingly AWOL from responding to him for a bit because I was in Taiwan, and I was lucky to be at the Hsinchu Science Park, which is where TSMC is located, where the incubator essentially that TSMC was born from is located. And the folks at the science park were walking us through all they do and all their partnerships, and they had a map of the US. And for context, I was on this trip with a group of economic development professionals from around the country and Canada, and there were folks from New York and Boston and Seattle and Houston, and I felt a little bit like I was kind of punching above my weight being there, being from New Mexico. And we go to the Hsinchu Science Park, and they have this map of all of their partnerships and collaborations. And the only state on there that had 3 out of the 9 total listed was New Mexico. UNM, Sandia, Arrowhead. And so I got very excited. And I think all my colleagues from, the other states were like, oh, New Mexico. Oh, okay. All right. They have stuff going on. So to delve into that a little bit, we've heard so much about Sandia, Los Alamos, UNM, about these core competencies that New Mexico has with quantum. But I think, and this might be perhaps a little bit more specifically for the non-scientists, non-lab folks in the room, does anyone care to give us a little bit more information about how does that really play out, right? How does your company interact with Sandia, or how has Sandia Tech or manufacturing led to something your company works on. I'd just love to hear a little bit more, so that we kind of flesh out what that picture looks like of how what happens here in New Mexico in quantum goes global. And anybody can start, yeah.
Maybe I'll move in that direction. So for me, the main influence right now has been, well, the workforce development, I guess. As I said, I did my PhD here. I work with other colleagues that also come from New Mexico. And I think that's something that New Mexico can capitalize on. When I was doing my PhD, I also was in Los Alamos, and that's also another place that has a rich history. It's one of the pioneering places as well for computation. So UNM, on theory, I came from Spain, to New Mexico, because that was and it's still one of the centers of quantum computing. So on that aspect, I think is mostly the workforce development. I think looking into the future, we are starting, we're developing hardware. We're getting to the point where we want to start doing more partnerships. Our quantum processors, experimental quantum processors, there is still a scarce resource. We are very focused on really building the technology, but we're getting to the point where we can do a lot of interesting science already. So we want to develop partnerships with industry, academia, national labs. And I think that's probably how that relationship is going to develop through partnerships where we offer use of our processors, and people in national labs, academia, in New Mexico and other places can use it to develop science. So that's probably one of the main areas.
I covered this a little bit in the prior talk, that have these big three: being close to your customers, being close to development partners, being close to the workforce. I think there's two others that I'll mention too that I don't know that people think about as much, but being in a place where there's affordable, you can live, you can have a family, and it can be very affordable. A lot of the quantum places outside of New Mexico, it's getting very hard to live there, especially if you're a graduate student starting, you can't buy a house right away. And I think that's another positive of New Mexico, is that people can live here in an affordable way. And then the other one I'll bring up that's that probably no one thinks about is it global warming? Long term, what's the global warming risk there? So in some of these places where quantum companies are, say the global warming risk is really high. And I think it resonates heavily with those of us in Colorado. We had a big fire. It was called the Marshall Fire. It wasn't that far away from many of the quantum companies, Atom Computing, Inflection, and Quantinuum. These are capital intensive companies that something like that could be very devastating. And so when you're looking at where else you could go, all the three things I said are the big drivers, but I also look at how sustainable or how robust is that place from economic catastrophes that are more driven by global warming. It's a little bit of a Debbie Downer. I'm sorry to bring that up. I feel like I've taken all the air out of the room by saying that, but it is something that these capital intensive companies have to think about.
So New Mexico understands and values science. I think that's the first thing I want to say. The second thing I want to say is New Mexico understands and values the fact that science stops somewhere and technology starts elsewhere, and that it's bringing scientists and non-scientists together to make things happen that really changes the world. So at Quora, we work with scientists in New Mexico in two different ways. And so I'm just, being diplomatic to call out both Sandia and also Los Alamos. And also it gives me a chance to kind of explain my philosophy on technology development a little bit. When you build quantum computers, your intention is to solve a large range of problems. And there's two types of innovation that have to go on. You have to make hardware and you have to make it work. So there's hardware innovation. Part of that is building things, in our cases, that use laser beams to manipulate single atoms and so forth, and make technology to do that. The other aspect is user-driven innovation, which is to say that once you have that hardware in place, how you use it really matters. How do you program a quantum computer? Nobody in this room can honestly say that they know the answer to that question. So we do both of these things in New Mexico in collaboration with people here. At Los Alamos National Laboratory, we have a lot of people who are working on use-driven innovation, who are using our computers. This is where that accuracy, that honesty, that integrity of a scientist really comes into play, because we would like people to use our machines and see that they really, really work. We'd also love that they share with the rest of the world that they work. So we work with Los Alamos very closely on that. In many ways, they're our kind of beta users of quantum computers, and we really love that collaboration that we have with them. We also work with Sandia National Labs, and this is where we get the technology arc of things as well. At Quera, we have to manipulate our single atoms with laser beams. So we work with Sandia National Labs to make integrated photonics tools. And we have actually some of the most innovative silicon nitride photonics on Earth. We actually have the world's record highest contrast optical modulator of light built into a little chip so that we can build thousands of these modulators and modulate the light that hits thousands of qubits. So both of those projects show you the hardware innovation that's going on, show you the use-driven innovation that's going on, but they really show you the strength of what New Mexico has going on in these two laboratories at Sandia and Los Alamos National Labs. I should also say there's an awful lot going on at the universities. Ivan Deutsch taught me some of the first things that I ever learned about how to use neutral atoms to do quantum computing when I was a young graduate student.
All right, well, I do have to agree with my colleague here that New Mexico has tons to offer in the neutral atom community at sort of all levels of the stack, right? So my colleague and I from Atom Computing actually came a day early because we had so much quantum business to do in New Mexico, and went, so all our colleagues at
This is what we
Sandia.
like to hear at the Economic
Yes.
Development Department, by the way.
So we went to Sandia yesterday. We went to University of New Mexico yesterday, and we're seeing our Lanel colleagues today. And really, there are enough touch points between all of these institutions. New Mexico has historically and is currently such a center of quantum science and technology that it will take us years to get through all the potential projects that we see. And you know, we look at enabling technologies. There are all kinds of enabling technologies that we buy off the shelf at Atom Computing, or we work with partners to develop novel things that we need to enable the quantum computers that we want to build, because we want to build the quantum computers and we want other people who are great at doing things in the supply chain to do that work and provide us with those solutions and allow us to help apply them. We look up the stack. We have experimental colleagues at Sandia who are manipulating neutral atoms every day, and we can have productive technical exchange about what we're each seeing in the laboratory, how we can lift the whole field and enhance our capability as a species to build these systems. And then looking up the stack, we also look for our colleagues at Lanel to deliver some of their excellence in algorithms and applications, participate in technical exchange, and look at things that will really transform the landscape when quantum computers reach their peak capability. And we're really excited to drive toward that goal in partnership with everyone who's working on quantum in New Mexico.
For me, the why New Mexico is easy. It's the people. Some things I didn't say about Xanadu, it's in Toronto, so not the US, it's in Canada. It's unlike working on matter-based qubits, it's photonic. It's purely photonic quantum computing. And on my team of 30 theorists, there actually aren't that many Americans, but such that we have, about half of them went through UNM. And they did their postdoc or undergrad or PhD there. That's because I think here the professors, Ivan, Akimasa, Elohim, and others, they've become really, really good at putting together, attracting really talented people and also molding them into such a strong and robust quantum workforce, as we saw earlier today, just how many of us also have spent time here. My needs are kind of a bit different from maybe what my colleagues are also after. But for me, I have research problems I need to solve, and folks that are in New Mexico or been through New Mexico are the best pick out of basically anywhere else in the US. Yeah, it's kind of a special thing maybe in our case because photonics is kind of not as widely pursued in the US, but New Mexico covers all its bases in terms of research. Yeah.
We're gonna put you in a marketing campaign, Raphael, just for the record, by the way.
So I think there are three broad buckets that that help New Mexico stand apart. The first is physical infrastructure and physical capital. And there are, material systems and devices that need to be built to accelerate the quantum future, that the only place you can do that is at CINT at the Mesa Fab in partnership with Los Alamos, Sandia, UNM, and that's where it's getting done. You also have companies like Star Cryo-Electronics that, my company sells dilution refrigerators. When you see the beautiful golden chandeliers of quantum, that's not a quantum computer, that's a fridge, and it's a fridge that often my company builds. And there are devices in those fridges that, when I'm selling a system to Germany, to Canada, to the Netherlands, to Japan, they request Star Cryo-Electronic squids that come from here in New Mexico, fabbed, built, designed here in New Mexico. So that's the physical capital piece. The second is the human capital piece. The intellectual leadership out of New Mexico is second to none. It is essential to our industry. You go to any quantum company anywhere in the world, and they will have hired folks from New Mexico who were, educated here, who did postdocs here, who became part of their team. Certainly the case for my company, clearly the case across the board up here. The third that has been really important over the last year is visionary leadership. Now that extends from things like QCamp and the workforce development leadership that's going on here to being willing to step up and put money on the line in a way that other states didn't. We saw that chart earlier where there was 40 odd million from the federal government, 76 million from Colorado, and 10 million from New Mexico. The important thing to note there is the 10 million from New Mexico was first. And the only reason that we got the other money from Colorado and from the federal government was because New Mexico stepped up and said, this matters. We have the capabilities. We're not going to let what happened with Microsoft happen with quantum. We're going to make sure that the work we invent here stays here, and we're going to invest to do that. And so I think those three things, the physical infrastructure, the human capital, and the visionary leadership at all levels, from teaching high schoolers how to engage with quantum, to winning Nobel Prizes, to having government leadership that's willing to say, we care about this, we're going to invest in this. That's what sets New Mexico apart. And that's what I've come to New Mexico for again and again.
Thank you. When we look at states in general, we have three criteria. The first one is, does the state have the viable ecosystem? And New Mexico definitely has it, both in terms of academia, University of New Mexico, research labs, Sandia, Los Alamos, by the way, very focused on atom-based quantum computers in general. We've had a long-standing relationship, and the number of our lead engineers come from Sandia. Enterprises, does the state have a number of enterprises that would benefit from quantum? Aeronautics, bioscience, clean tech, all will benefit from quantum. And then startups. So when you look at New Mexico, you have the foundations to be a quantum capital. That's important for us. That's the first criteria. The second criteria, this does not mean that the ecosystem is going to start humming on its own. There's a need for leadership and for investment, smart investment by the state and potentially the federal government to get this flywheel turning. We're starting to see some states invest significantly. Illinois is an example, $500 million, and they've attracted a lot of federal spending as a result. DARPA, $140 million, matching, NSF, et cetera. In the United States, we're not going to have 10 quantum capitals. We might have 3, 5. So we're looking at those potential areas that might be a quantum capital. We believe that New Mexico, with the right big bets, can get there. And those have to be smart bets. Just throwing money at the wall, hoping that something will stick, is not going to work and will cost too much. One of the directions that Illinois did is that they created a shared capacity, if manufacturing capacity around cryogenic refrigerators. And that helps some of the quantum manufacturers. For the atom folks around this room, that might not be the most important. But what's really important is integrating lasers on chips, is being able to create these traps for the atoms that we are creating. Nobody has taken the lead yet in the nation. There could be a huge opportunity in New Mexico if New Mexico decides to take the lead there. And I would say the final point for us as a company to move into a state is to have the possibility to have an anchor tenant strategy, to be able to anchor one of our systems that will be used by the broader community and the ecosystem to build value around it. And there might be other systems anchored if you're creating this manufacturing capability in the middle that's relevant to all of that. And then the incentives to bring manufacturing into the state. So that is the lens that we're looking at. We would love to be on the journey with New Mexico. We believe 2025 is going to be a critical year. There are numbers of states that are starting to move, and time is not the friend of those who wait, because there will be only a few opportunities. So bold move, smart investment, 2025, and we would love to be with you on this journey.
I think this is a really good point. And, you know, the question was why New Mexico? And I think we've sang the praises of New Mexico in the right way. These are the things that New Mexico has to work with. But I think that the next question is, okay, so now what? What should we do? And I think it's important to really understand where quantum computing is at right now. We are not producing machines that are out calculating classical machines yet, but we are getting close. I really believe this, right? And we're getting close enough that if you start training an individual to contribute to this field, by the time you are done training them, we might be there, okay? So the hardware innovation has reached a point where we're within shooting distance. I believe that this is true. The use-driven innovation has to start now. How do you program a quantum computer? I don't know. Nobody in this room knows. We have to figure that out. We have to start using these things before they are really useful for real-world problems. And part of that is that we have to start thinking about this as a technology in translation and start putting the mechanisms in place to do that. That means that we need to make a few more of these machines. Do we need to mass manufacture them? Not quite yet. But do we need to figure out how to manufacture them in a controlled way? Absolutely. New Mexico can help with these problems. So I think, you know, this is kind of the clarion call. What can we do next? And I think for many of the companies up here, in fact, maybe all of the companies up here, we're just at this kind of transition point where we're starting to figure out what it is that we need to do, and we need to do it at a little bit higher scale.
Well, the two of you, I'm just going to skip ahead to one of my questions that you have so wonderfully led me into. Looking at the future of the industry and here in New Mexico. So Corbin, I've heard you say previously, you know, leadership today doesn't necessarily guarantee a lasting advantage. So what will, you know, I want to hear from you, what exactly should New Mexico be investing in and prioritizing? And, you know, when I work with my legislative partners, I know Representative Dixon is here somewhere. They want to hear, you know, what is the programmatic aspect or the investment that will yield that result. So what policies, what incentives, you know, can stack on top of the core competencies that New Mexico has already to be particularly compelling to your company or to future companies to build out quantum in New Mexico?
Yeah. So the way that I think about this is, you know, when I wanted to leave BCG and get involved in quantum, I sat down with a bunch of leading qubit builders, and I found out pretty quickly that every single one of them, no offense to those on the stage, can look you in the eyes and with passion and conviction and good arguments explain why their qubits are the best qubits, the only qubits that can reasonably scale, the highest fidelity, the highest interconnectivity, you know, the best path to error correction, whatever the answer is, they have good arguments for why theirs are the best. And I realized pretty quickly that as a non-physicist, I had no hope of figuring out who was right or wrong among them. And that's why I became a refrigerator salesman, right? that this is a technology that almost all qubit modalities have to get cold. Most of them have to get extraordinarily cold, and it was a way to diversify the bet. And I think that logic actually extends to state level investments, and it's exactly what Jake Douglas and Zach Yerushalmi talked about. Investing in underlying capacity building that is useful to the entire industry. Right now, you've heard us all talk about Sint and Mesa Fab. They're incredible facilities for research. They do not allow for commercial production of the devices that you build there, right? Having commercial fabs that are open access, not research fabs, focused on yield and throughput and the quality of the devices, investing in that the way that they did in Hsinchu when they decided to lead the semiconductor revolution there, that can be incredibly impactful. Investing in scaled cryogenics, so not necessarily just the 10 millikelvin level where my company focuses, but everybody has to have some elements of their system at a few Kelvin. You know, when folks talk about not needing as advanced of cryogenics, they're talking about the difference between negative 273 Celsius and negative 269 Celsius, right? It's all pretty cold. It is easier to go to 69. I'm not dismissing that at all, but investing in scaled cryogenics that are broadly applicable. Chicago's made a big bet there. I don't think they've made it in the most prudent way. It's pretty focused on one customer, one use case. And doing one that is more generally applicable, I think is incredibly impactful. And then the third thing that's part of the NSF proposal, but I think the state could step up in a big way, is these moonshots, these grand challenge based prizes. The reason I love those so much is it makes it so much easier for every company on this stage that isn't working on the infrastructure layer to attract the next round of private capital if there's a clear goal where if they can, you know, factor shores with a certain level of complexity, they're going to get $500 million cash as a prize. That makes it so much easier for them to attract that next bite of private investment into their company, right? Or if they can model a molecule of a certain level of complexity. I realize factoring shores makes people nervous because it breaks encryption eventually. So maybe we do molecular modeling. It's more friendly. But there are things around capacity building, infrastructure, and grand challenges that I think for governments are the most efficient way to spur the industrial side of research. And then in addition to that, you need to continue to invest in fundamental research and the workforce development and education around that, because no one else is going to do that. And so continuing to support UNM, Los Alamos, Sandia, CNMU, the other universities in the region that are part of this, make sure that they have the resources they need to feed this pipeline of innovation.
Yeah, I want to double down on that scientific research and workforce development. I think it's really important to build on the solid foundation that New Mexico has already established. Like, look around at the community that's been established here, that's been gathered here today. And that's just for this workshop, right? New Mexico was able to put out all of its connections, all of its collaborative relationships, and gather a world-leading community of quantum computing and quantum technology practitioners here. And I think that's so important. And building on those partnerships, building on those relationships, building on collaboration with the quantum community writ large, it's going to take all of us to realize the challenge of quantum computers. I really believe in those iterative development loops and the way that they are fed by new ideas, which is my second point, which is, I'll go back again to the meetings that we recently had with quantum groups all across New Mexico, and everywhere there were students, right? And everywhere there was student-driven work, and everywhere there was beautiful progress being made and new ideas being advanced by this generation of graduate students that I agree that is going to be at the forefront of real utility scale implementations of quantum computing. So yes, make big bets. Yes, press the technology forward, but treat the students well, foster the new ideas that they bring and the way that they connect with the way that this technology is going to land and be implemented and drive the community forward. And I think that, you know, as the students go out and launch companies here, work elsewhere and bring their relationships back to New Mexico, you'll see it continue to grow and continue to develop.
I'm just going to summarize, and I'm going to keep it simple. Bring good people here, close the door, wait a little bit, and it'll happen.
So yeah, I'm gonna speak obviously not as a Google representative, but you know, from my personal experience, so you can see the, you know, the companies that are represented here and also the quantum effort at Google. Everything starts in a university or in some partnership with university and national labs. That's how all these companies start. At our group, which is, you know, the hardware group is in Santa Barbara. We're hiring, you know, a few hundreds of people. We're investing in buildings. It started in the University of Santa Barbara, UC Santa Barbara. So public investment does work. And, you know, in the long term, it certainly does bring jobs and industry. And, you know, as an example, even though Santa Barbara is very expensive, because we started in the university and we needed access to the lab, that's why we grew our quantum effort there. Well, and it's in the time zone, you know, for Google, it's a convenient time zone because it's Mountain View time zone. So I think that's the first lesson. And the second one is hardware is very important. Well, actually, I'm going to say, just in case, we're still at the, you know, starting point of the second quantum revolution. So, you know, the field is open. It's going to take time and investment to really land this revolution. New Mexico has been pioneering, you know, the second revolution for more than 2 decades, 3 decades. But this is we're still at the early points. So I think it's still a place where public investment, and New Mexico, you know, obviously has the workforce, we talk about that, and obviously has already the inertia and the institutions, you know, with the national labs and the university. So, but, you know, these companies tend to grow out of some hardware hub. So maybe, and I think it was mentioned already, some sort of initiative where there is, you know, a hardware hub that develops some kind of technology, and where technologies grow around that, then that's where you are going to see startups or efforts from, you know, not the startups, but groups growing there because they have the, you know, already the workforce, already the institutions, the critical mass, but also the hardware. And that's how startups grow next to academic or national lab institutions.
Excellent. I know I'm standing in between everyone and lunch, so I don't want to belabor the point, but if everyone could please give me a round of applause for our wonderful panel. Thank you so much, everybody, for being here and for joining us for this discussion. Many more, you'll get follow-up meetings from my office, so many more discussions to come, and I'll turn it back over.
Sure, yeah, this sounds great.
Go for it. You here.
Thank you.
Yes.
Yes, so this is fantastic. But I want to stitch together a couple of things I heard. Matthew Shenik, CEO of some startup companies, now an investor, looking to figure out how to get into quantum and looking at the private sector focus on quantum. So I heard talk about there aren't going to be, you know, 10 centers for quantum, there are going to be 3. So we got to move there. I heard it's going to be 35, 40 years. I heard focus on the investment. Okay, maybe 10 years, right? 5 years, 10 years, okay. So, you know, go now, don't go now, right? What I didn't hear all the talk about here is the private sector focus in terms of companies. You met with a lot of institutions while you were here, but how many companies, private companies, bottom line focused companies you meet with while you're here? Now, I bring this up because it's something that we're growing and developing here. We want to get this going. The guys have done a phenomenal job with all this. If I was to look at Google and say, when the state is going to put money to work, what would bring Google here to put a center here that would start to develop that private sector where you create a supplier network around it? What would it take? What would it take for any of you with private sector companies that you could say to EDD, he could say to our legislator, if you guys were to do this, we would be a part of that. We would come in, we would help get it going. But one of the things that concerns me is all the talk about how great New Mexico is, talks about workforce, education, research and development. That's stuff that's easily transportable out of the state. We don't want that. We want it to stay here as much as we can. STEM boomerang is wonderful, but we don't want to wait 3 or 4 years until people start coming back. We want to try to get it going now. So my question is, what would it take for the companies that are here to start putting money to work in New Mexico, to start building up that infrastructure where we get some startup activity going, so I can put some of my own money to work?
Thanks, Mathis.
So that's, maybe I shouldn't say this, but I work with a lot of states on how to get quantum technologies off the ground. At home, I'm famous for my filing cabinet. And what I say is, I work in a relatively small company, but it's growing very fast. I have 60, 80 people. I have to make choices every day, and I have a supply chain to worry about. I have certain components in the machines that I build that there are literally 4 people scattered across Earth that know how to build. And some of them live next to very, very busy streets, and I'm worried about those buses running into them. And, so that's a case where I really should develop those materials in-house, right? I should vertically integrate. But I have 60 people, right? And I need to focus, right? And all these adages about how does tech get off the ground, right, come to mind. So I put them in my filing cabinet, right? So this is my filing cabinet of value propositions for the supply chain. And the question is, how do I, work together with states? And how do I think about this ecosystem that has to develop? I know how to make those things that only 4 people on Earth know how to make, right? I can share that information. I have found that many states, and there's a part of me that strongly suspects New Mexico is one of them, where there are literally people that know that they want to be an entrepreneur, but they don't know what their value proposition is yet. And they know, I want to start something and I want it to be important, but I just don't know what to make. Well, I got this filing cabinet, right? And I want to share that filing cabinet because that's in my interest to shore up that supply chain. And it's in the state's interest to build that budding ecosystem of people that contribute to this. I will gleefully teach them the techniques that make this specific component. And, I'm not sharing which component it is because I'd like to find that budding entrepreneur and pick just the right one, right? If they're in New Mexico, I'm going to come to New Mexico and I'm going to help build that. And I think we should all be doing this.
What you point to is exactly the challenge that New Mexico faces. Like, no question, that's it. Brilliant people educated here and then going to Colorado, Toronto, Colorado, Maryland, wherever, in order to build the companies. The way to fix that, in my opinion, is by making it so that iteration happens faster here than anywhere else in the world, because that's what will lead to successful startups. Ultimately, that's 3 things. You have to be able to come up with the stuff, design it. You have to be able to build it, and you have to be able to deploy it. And in quantum, the things you need to do those 3 things aren't actually secrets. On the design side, you need the education. You have that here. Then you probably need dedicated supercompute, right? That can either be done in partnership with Los Alamos or Sandia. They have some of the biggest supercomputers in the world, or with a net new supercomputer that's dedicated to this. But you can't do it with cloud-based supercompute because you can't get enough GPU clusters dedicated to the things you need to do this. On the build side, it is fabrication, and it's commercial fabrication. Partner facilities to Mesa and Sint that focus on fabricating photonic integrated circuits with critical materials that focus on fabricating superconducting devices. The nice thing about the superconducting devices is nobody in the US is doing that. Colorado is now doing PICs. So if I were recommending something, I would say build a superconducting fab. That will piss off everyone on the stage, except Google. Google likes superconducting fabs. But if you have a fab that's capable of heterogeneous packaging and superconducting devices It will be easier to do that here than anywhere else in the world. And then the third is that deploy piece, which for early stage companies means you have a couple fridges, a couple clocks, couple frequency combs, bunch of lasers, and some, advanced cryogenic systems in a room. And a startup can go there, and instead of having to pay millions of dollars upfront to get access to that stuff, they can rent it on a weekly rate, so that if you are a seed or Series A investor, you aren't talking a $10 million round, you're talking a $1 million round for this group to prove that what they're doing is important and different. And then they can go raise their 10, 20, $30 million, right? So if you have those three things, it'll make it easier for early stage folks to be here than anywhere else in the world. And it'll attract some mid-stage folks. For the big guys, you're gonna have to buy their systems. And that's expensive. But that's what will get an IBM or a Google or an IonQ or an Atom or a QEra or somebody else to say, we're going to put 30 people on the ground here, is if you decide to go in heavily on their specific quantum computer. It's higher risk, but the upside is there if you make the right bet. You guys can tell me I'm wrong, but I don't think I'm that wrong.
So, we're a public company, so we're probably at a different stage of the evolution. For us, I would agree with my colleague here that building some manufacturing capabilities so that we can scale is critical. And whether those are cryogenic refrigerators or integrated photonics on chips, we can debate that. But building the ability to scale is important. The second part is not just the manufacturing ecosystem, but the quantum ecosystem in general. So the startups, the universities, the students, so that the software element can be added, so that the quantum communications and sensing can be added. When you think of Silicon Valley, it's not just chip manufacturing. There is much more to that if you want to become a quantum capital. It's important for us to see the leadership and the investment to build something that's broader than that. And to your point, tactically, yes, having a system here, and it could be one of many, right? And perhaps a common denominator related to the manufacturing capability that enables multiple of these systems is important as a way to start getting people acquainted with our technology, and then giving us the incentive in addition to whatever manufacturing incentives you have in place to move here. So I think we have a vision. We've developed it in some places, including in Switzerland, in the US, in different places. We're happy to share it. We started discussing it with the governor's office, and we can talk more. Keep in mind that there are always two key drivers of why people are investing in quantum today. There's the ROI, return on investment, and there are the mission-driven. And your government is often on the mission-driven part, trying to put the foundation so that the ROI at some point takes over and the private sector doesn't need any intervention anymore. If you think about AI, machine learning, it's all ROI-driven. You don't need government intervention anymore. I think we are one curve behind.
Well, this will be our last add-on, I think.
So
then we'll wrap
yeah,
up.
lunch. One last thing. Let's not forget about use-driven innovation. And new companies can also be centered on that. This industry misses one thing for that to really work. I mean, really what all of us are platform developers, and building the software that runs on quantum computers is use-driven innovation. We need to find a way to reward the people that do use-driven innovation in a real way. We need to find a way to protect their intellectual property, and we need to find a way to give them access to these quantum computers to develop on. And that will spur a lot of new companies and a lot of monetizable intellectual property. And we need to get into that phase soon.
What a fantastic conversation. Thank you so much, guys, for joining us. Really appreciate it.